So if you like this one, I'll be motivated to do another great one, hopefully by tomorrow. Now, before we move on, if you're not currently subscribed to this channel, I think it would be a great idea to hit that subscribe button now, because we have some amazing content for you and we do not want you to miss out. Thank you. Now, what is the chain rule for differentiation? The chain rule is a method of differentiation, but the question is, how do we use chain rule and when do we use it? So now let's go into what I prepared for you. So the chain rule is used when you want to differentiate a function that has a subfunction. For example, when we have y equal to x plus 1 all squared, see here, y is a function of the square of x plus 1. And now the function x plus 1 in brackets can be represented by another function u. So you see the correlation, y is equal to the square of u and u is equal to x plus 1. So the question of when do we use it has been answered. It is used when you want to differentiate a function that has a subfunction. If the question of when do we use it has been answered, now how do we use it? That's why there's a formula for it. So the y dx is given as the y du multiplied by the u dx. What this means is that u is a function of x, differentiate u with respect to x, y is a function of u, then you differentiate y with respect to u, as simple as that. So then you multiply both of them. So differentiating y with respect to u, according to this question, we have that y is equal to u square. So the y du is equal to 2u, and u equal to x plus 1. Differentiating, we have the u dx equal to 1. Guys, now I want to make an appeal. If there's any problem you have with differentiation, you can state that in the comments section. So I'll work out a video specially made for you. Thank you very much. So now let's go back to the solution. So the u dx equal to 1. Now let's fit in the entities. The y dx equals to the y du times the u dx. So the y dx equal, the y du is 2u, then the u dx is 1. So multiply, we have the y dx equal to 2 into brackets x plus 1, because u is equated to x plus 1. Now let's see what we have here. Y equal to e raised to the power sine x. So we have to differentiate this equation, whatever. So generally, there is a table of standard derivatives which you guys need to know. So the derivative of e raised to the power of x is simply e raised to the power of x. So now here we have y equals to e raised to the power sine of x. So y is a function of e, and e has another function of sine x. So u is equal to sine x and y is equal to e raised to the power of u. So the y du from the table of standard derivatives is equal to e raised to the power of u. And u being sine x, derivative of sine x gives cos x. So the y dx is equal to the y du times the u dx. So e raised to the power of u times cos x, that is cos x multiplied by e raised to the power of u, which gives cos x multiplied by e raised to the power of sine x. Now that was quite easy. Let's move to the next one. So what do we have here? Okay, we have y equal to tan cube of x. This means that tan x multiplied by tan x multiplied by tan x. So that's what tan cube of x means. So u is equal to, let's say u is equal to tan x. So u is a function of tan x. Now y is equals to u raised to the power of 3. So because we have tan cube of x, that means y is equals to the cube of u. and the derivative of tan x gives sec square x, and the derivative of u raised to power 3 gives 3u squared. So the y dx is the y du multiplied by the u dx. I'm sure you would have known how to find derivative of using chain rule. So that's 3 tan square x multiplied by sec square x. Next, you might want to try this on your own. So we have y is equal to cos x minus sine x raised to the power of minus 2. So let u be equal to the items in the brackets. So u is equal to cos x minus sine x. Then y is a function of u raised to the power of minus 2. So y is equal to square u raised to the power of minus 2. So differentiating y with respect to u, we have minus 2u raised to the power of minus 3. And differentiating u with respect to x gives minus sine x minus cos x. So the y dx is the y du times the u dx. So which is minus 2u raised to the power minus 3 times minus sine x minus cos x. So the y dx finally is minus 2 into bracket cos x minus sine x raised to the power of minus 2 multiplied by minus sine x minus cos x. So it's quite easy. Next, please take a careful look at this question. Y is equal to cos tan 3x. Look, y is equal to the cosine of the tangent of 3x. Now we can only answer this question by using the chain rule twice. Here's what I mean. Y equal to cos tan 3x. I would like to separate these functions. So let's take tan 3x first and call it f. So f is equal to tan 3x. Now in this f equal to tan 3x, let's say u is equal to 3x. So f is equals to the tangent of u, and if you differentiate f with respect to u, you have sec square u. Now coming back here, u is equal to 3x, right? So the u dx is equal to 3. Now the f dx is the f du times the u dx. So 3 multiplied by sec square u, so that is 3 sec square u for the f dx. Now coming back to the original equation, y is equal to cos tan 3x. Remember, tan 3x is equal to f, so y is equal to cos f technically. So differentiating y with respect to f, we have negative sine f. So now the derivative of this equation can be gotten by saying the y dx is equal to the y df times the f dx. So we have the y df as negative sine f, the f dx as 3 sec square u. So and negative sine f is negative sine tan 3x, and u is equal to 3x. So let's plug in minus sine, instead of f we write tan 3x times 3 sec square 3x. So the answer is, okay, the y dx is equal to minus sine tangent of 3x